going to define what a midsegment is. So our definition of a midsegment is a segment that connects two midpoints. Okay, and we know what a midpoint is, right? A midpoint is some point in the middle of a segment, right? It splits the segment right in half. So what they're saying is you're going to have two lines. Each of them have a midpoint. The mid-segment is going to connect the two midpoints across two lines, okay? There are two properties of mid-segments as well. The first property is that a mid-segment is parallel to the side it is opposite. So whenever you draw your mid-segment in, it's going to run parallel to the side across from it. Okay, the second property is a mid-segment is half the length of the side it is opposite. So the line that it runs parallel to, it will be half the length of, okay? All right, so we are going to draw in some mid-segments here. It's not important that we're accurate because, well, as we know, we're not supposed to trust a picture completely anyway, right? Unless they have some given information, we're just going to go based on markings, okay? So we'll mark this to have what would be mid-segments. Okay, so if you were going to create a mid-segment, okay, your first step would be to find the midpoint on, in this figure, we would be looking to find the midpoint on all three of the sides in our figure, okay? So find midpoint of all three sides. Okay, so we are just going to estimate where exactly those midpoints would be. So just make sure you put it at somewhere that looks like it would be the middle of that side. Now, if that point is a mid-segment, if that point is a midpoint, that means it splits this segment into two congruent pieces, right? Same thing over here. If I put my point here, that would mean that this segment and this segment should be congruent in size. And same thing down here on the bottom. All right, so we have all of our midpoints, and we know that just means splits that line in half. The second thing that we would do would be to go in and connect all of these midpoints. Okay, so if I connect this point and this point, that's a midsegment. So I just connected two midpoints. Okay, I can do the same with these two midpoints and these as well. Okay, and then the last thing I'm going to do is go in and label those midpoints, give them a name. So label my midpoints. I'm going to label them A, B, and C. So I'll label this one A, this one can be B, and this one C. All right, so now I'm going to make sure that these meet the properties that we said that a midsegment should meet. So if I look at this segment right here, AB, it's supposed to run parallel to the side that it's opposite or across from. So that would be this line down here at the bottom, which it does run parallel to, right? And then the line segment here is supposed to be half the length of that line as well. Well, we don't have a ruler out to measure, but it looks pretty accurate, right? Probably about half the length. Okay, the same should be true for these others. This line here does run parallel to my line with point B, the one across from it, and does appear to be about half the length of that line. Same thing for this segment here, BC, runs parallel to this side over here, A, and does appear to be about half the length. So, the segments I created here, AB, AC, and BC, are all mid-segments. All right, typically you will not be asked to draw the mid-segment yourself. What's going to happen is they're going to give you a figure that has some mid-segments in it, and then they're going to ask you to solve for missing pieces using these two properties right here, okay? So on the two or three figures below, we're going to fill in the information that would be given to you in a question, and then we'll solve it, okay? So on example 1, let's say that you were to put a midpoint here and here, and you draw in your mid-segments. So that means I know those two pieces are congruent, and those two pieces are congruent, right? So maybe they give you this drawing as a question on the test or on a homework assignment, and they tell you your mid-segment's length is 3x, and the side opposite your mid-segment has a length of 48, and they want you to solve for x. So using those two properties that we just mentioned above, what could we set up so that we could solve for x?
3x times 2. 4x divided by 2.
So one of the two, you either are going to have to divide something by 2 or multiply something by 2 because those are not equal, right? This one is half the size of this one. So I either have to double the small piece or half the long piece, either one, okay? Because this actually is an even number, it works out easily to half it. So I could say that 3x is equal to half of 48. Or I could say 2 times 3x equals 48. Either one would work. All right, what is half of 48? Good. So I have 3x is equal to 24, so x must be good. Okay. All right, let's say you had a similar problem. This time they're going to put your midpoints on the bottom and right sides. And so your mid-segment runs from here to here. So you know you've got your congruent pieces. Let's say this time they tell you that your mid-segment is x plus 2, and the side opposite of your mid-segment has a length of 20. So now what would we want to set up so we could solve for x? You could do that. Or we also could, right, half the 20. Either one works, okay? So if I half my long side, I just have that x plus 2 is equal to 10. So what is x? Good. Good job. Okay, so we kind of understand now the property for how to find maybe a missing side length or a missing piece within a side length. Now let's talk about using that other property. So let's say you're given some triangle where you have a midpoint here and a midpoint over here and that mid-segment in between. Okay, I'm going to give these points some names. Let's say this is point A and D, and then I'm going to give my vertices down here some letters as well. We'll do E and F. Okay, so let's say you're given the information that angle E right here is 80 degrees, and that the angle F is 50 degrees. Okay, so this time, knowing that that mid-segment is half the bottom isn't really going to help me out, right? But what did that other property say? Right, those lines are parallel. Good. So I can mark that this segment and this segment are parallel lines. And if I have parallel lines, what does that mean? We can have different kinds of angle pairs, right? We could have, I heard somebody say, some congruent ones. Also, we have some same side interior that are supplementary, right? So that could be helpful. Okay. So, because we know that these two lines, AD and EF, are parallel, we might have some different types of angle pairs. So let's say that they asked you to find, I'm going to ask to find this one right here. I'll call it B degrees, and this one right here, I'll call it A degrees. Okay. So this one here is my lowercase b. That's kind of hard to read, isn't it? I'll try again. And then say that's B degrees right there, and that one is the A. Okay. All right. So let's say we're trying to solve for the one that we've labeled as B degrees. Is that an angle pair with one of those ones we have at the bottom? Which one? E. What kind of angles are those? Corresponding. Very good. And what do we know about corresponding angles? Perfect. So we know that angle B is congruent to E, meaning they have the same measures, so we know angle B is also 80 degrees, because like you guys said, those are corresponding angles, which we know to be congruent. Very good. Okay. Now again, because we know that we've got those parallel lines, AD and EF, is there anything that we know about the one that we labeled A and one of those angles that we have the degree for at the bottom? This lowercase a here. Is that a type with either of those ones below? Same side interior with F. Very good. Okay. So what does same side interior mean? Supplementary. Okay, so angle A plus angle F, which we know to be 50 degrees, has to equal 180. So what does that mean that angle A is? Good. Because like you guys said, those are same side interior angles, which are supplementary. Very good. So those parallel lines could be helpful in finding missing angles, and then knowing that your mid-segment is half the length of its opposite side could be helpful in finding missing side lengths. All right? Okay, so that's what we need to know about our mid-segments. If you'll flip it over onto the back, we're also going to talk a little bit about perpendicular bisectors. All right, so first we're going to define what a perpendicular bisector is. This is going to be a segment, line, or ray that intersects a segment at its midpoint and forms a 90-degree angle. So basically, a perpendicular bisector is going to be exactly what its name says. We know that a bisector means to cut something in half, which is what it says it does, hits at the midpoint, and the line is going to be perpendicular, meaning forms a 90-degree angle. Okay. All right, and there are also two properties that we need to know for our perpendicular bisectors. The first one is that any point on a perpendicular bisector is equidistant from the endpoints of the bisected segment. Okay, so first we're going to draw in what a perpendicular bisector could be. We said that it has to intersect a side at its midpoint, and if it's perpendicular, that means it runs the exact opposite, right? So that it'll form that 90-degree angle. So let's say we wanted to form one on this bottom line here. So I'm going to put a point where I think the midpoint approximately would be, okay? Which means that these two pieces should be congruent in size, but a perpendicular bisector is a line. So it has to come from the other side and hit right at that 90-degree angle. Okay, what they're saying is that any point that falls on this perpendicular bisector that we just created, doesn't matter where it is, you can pick any point that falls on this line, and it is going to be equidistant from the endpoints of the segment that it's intersecting. So from here to here, and from here to here, going to be the same size. Okay? And that's true no matter where that point falls on that line. It's equidistant from the two endpoints. Okay? Now, the next property kind of piggybacks on this one. Okay? This one says, if a perpendicular bisector intersects a vertex of a triangle, the triangle is isosceles. Okay, so I'm going to draw in another perpendicular bisector on this. So remember, a perpendicular bisector has to intersect right there in the middle. And then the line has to run perpendicular to that line to be a perpendicular bisector, so it comes straight down. So if you notice, the difference between this perpendicular bisector and this one is that the side length over here was a little bit longer than the other. So my perpendicular bisector hit in the middle of the side over here, while my perpendicular bisector in this one intersects at the vertex of a triangle. Okay? They're saying if this happens, then you have to have an isosceles. Reason being, we said any point that happens to fall on that line, including this one, is equidistant from these 2 points. So this side and this side should be equidistant from our 2 points. So basically the same rule, it's just that it has to intersect at the vertex in order for us to be able to see that. Okay? All right, so keeping that information in mind, let's look at solving a couple of examples here. All right, on example 1, it says to solve for x, I'm going to name the point that they chose for intersection here. I'm going to call that point B. Okay. Well, if this is a perpendicular bisector, which it does appear to be, because we got the 90-degree angle and it split it into 2 congruent segments there on the bottom, what do I know about the 2 pieces that they marked as 24 and 2x? They should be congruent, right? Okay, so since point B is on a perpendicular bisector, then we know that we can set those 2 equal to each other. 2x equals 24. So x must be, good. Try again. There we go. Good. All right. So keeping that same idea in mind, on the next example, we have 3 different pictures where they ask us to find the length of the side AB on all 3 of these. Okay, so on number 1 in this example, side AB would be this one here. What kind of a triangle is this going to be? Right, because we have a perpendicular bisector that is intersecting at the vertex. Very good. So I know I have an isosceles triangle. So what does that mean about the side AB and the other side that has some values listed for it? They're congruent, right. So I should have that 2x is equal to 5x minus 6. All right, so what would I do first? Good. So now I have negative 3x equals negative 6. Therefore, x must be good. All right. So x is 2, but they want the length of the side AB. So I would need to take that and substitute it in, right? So I'm going to have that side AB is equal to what was 2x, we now know to be 2 times 2. So AB is good. Good job. All right. On number 2, what kind of a triangle do we have? Another isosceles, just turned on its side, right? Okay, so I have another isosceles triangle. So what can we set up here? Good. All right, so I'm ready to solve. What am I going to move first? The 3x, okay. So then I would have 4x over here. Then what else do I need to move? Add 16. What is 8 plus 16? What did we say? Good. All right. So what is x? Good. But they did ask for side AB, so I would need to take that and substitute it back in, right? So I've got AB is equal to 3 times 6 plus 8. So how long is AB? How much? 26. Good. All right. Last one. So what do we have going on over here? 2 triangles, right? Okay. And we do know they have a shared side, right? That shared side apparently has a midpoint at E because it shows that it split it into 2 congruent pieces, right? Okay. If this angle right here that they marked is 90 degrees, what do I know that this angle would be? Also 90 degrees, because those would be what we call a linear pair, right? They're on a straight line, so got to add up to 180. Good. And same would be true all the way around, right? They would all end up having to be 90 degrees. Okay. I'm only concerned with finding the side labeled AB, which would be this bottom section here. So that's on the triangle to the left, right? So I'm not really concerned about this triangle over here on this side. I'm only concerned about the triangle on the left where my AB is. So what could we set up now knowing that we have what kind of a triangle? Another isosceles. So what might we do with those 2 sides? Good. All right, so what am I doing first? Good. After we subtract 11x, then we would need to subtract. And what is negative 9 minus 11? Very good. So we end up with x is equal to 4. Nice. Oops, let me move the whole thing again. Okay, so I have that x is equal to 4. I want side AB, so I just need to substitute that in, right? So AB is equal to 11 times 4 minus 9. So side AB is, very good. Alright. So, as long as you know what the properties are, the math, not going to be too difficult. You just have to remember what the properties are so that you know what you can set up. Alright?